Okay, now x values are fixed. Okay, that is, x values are fixed. Fine. So you can say this, that x is non-random in repeated sampling. X is non-random in repeated sampling. So what exactly it means? Suppose you have the model y equals to beta 1 plus beta 2 xi plus ui, clear, and you are trying to find out how to actually fit the line. Okay, so what will you say is this: you have this x and here you have y. Okay, now I give you, say, x is equal to 2. Okay, fine, and you guys have given me some y's. Okay, then for the other sample I've given x which is equal to 4. Okay, they've given me some y's. Similarly, I've given you guys x equals to 6. I got some values of x, of y. Okay, and each of these values, they will have a distribution around their mean. Okay, they will have a distribution around their mean, and you can connect them, and actually you want to fit this line. Okay, this is your sample regression function. The only thing is that x's are non-random. Okay, later on you can even relax this assumption of x's to be non-random. Okay, but it will have its own kind of problems. Okay, it has for a given x, it has a certain y population. Okay, which is distributed around its mean value. Okay, with some y's which are above the mean value, with some y's which are below the mean value. Okay, the distances above and below the mean values, they are nothing but the residuals. Okay, all of these distances, these are nothing but the residuals, and on an average, okay, that is of course that's the next assumption. Okay, that is, but on an average the error term should have the zero mean. But the only thing for this value, for this assumption, is that x values are fixed and x is non-random. Okay, x could even be assumed to be random. Okay, in case if you write x is equal to, say, x star plus e. Okay, e is some, and what you actually have done is that in your model you have run the regression with x and not with x star. X star is the true x. Okay, actually x star is a true x, but you have run the model with x and not with x star. Okay, if you would have run the model with the true value of x star, then this error wouldn't be there. But since you have estimated the model with this x, so this error is always there. Okay, and this has increased the amount of this error also. Okay, so you can probably say this, that x's are non-random later on, but right now, and we'll talk about that when x's could be non-random. But right now what we are saying is that x values are fixed. Okay, they are assumed to be non-random. So for a given x, you will have a certain y population. For another given x, you will have a certain y population. So x's are assumed to be fixed in a repeated sampling. Okay, so what you will actually do is that you will say this, that okay, for an education level of, say, 10 years of education, what is the level of income of the people? You will see this. Okay, then for for the education level of say 12 years, what is the level of income of the people. So you're keeping the education level fixed, and then you are seeing that how is Y changing. Okay, so this is there. Okay, fine, thanks.